Good afternoon, ladies and gentlemen. We are on our last skill of day one. There will be a mastery over Unit 1 probability at the beginning of next class after a little bit of review. So I am going to put these important ideas again up about probabilities and conditional probabilities. So if you do not already have these from your 1.2 notes, make sure that you do have these because these are pretty important in defining what it means for something to be mutually exclusive, what you do with the OR problems, how you add the two probabilities and then subtract the overlapping case. And then we're really going to be focusing on conditional probability. So what's the probability of A given that B has occurred? And of importance is covering up the sections that you no longer need, and then you just answer the question. So this is a conditional problem with two-way tables, kind of a basic one. This is asking, what is the probability that a female student does not have an A? So this problem is not asking about male students. It's asking about female students. So therefore, what we need to do is we need to cross out male students and just focus on the female students. And it's asking us, what is the probability that the female student does not have an A? So the total female student is 14. So we're looking at probability not A over, or number of not A, I should say, over number of female students. So there are 12 females that do not have an A. There are 14 female students overall. So that 12 over 14 simplifies to 0.857. Or we could put this in simplified fractional form. So this would be 6 out of 7. We also have probability given probabilities. So these on Delta Math, you want to make sure that you kind of draw these tables. This looks like an earful. We have Yankees winning the games, and also whether they get 5 or more runs or they get fewer than 5 runs. So in theory, when a team is able to have more home runs, they are more likely to win the game. Let's see if this is actually the case. One thing that we know for sure is that the probabilities do add up to 1. And we want each row to be able to add to 1. Or I should say each total to add up. So like 0.44, and then this would be like a 0.56, add up to 1, and then 0.4 plus 0.6 equals to 1. And then if I want to do 5 or more runs and lose, I'm going to do 0.4 minus 0.34 to get 0.06. And then I can actually fill in the other information as well. So this is going to be 0.38. Because I want that to add up, so I could do 0.44 minus 0.06, and then I have 0.38 and 0.6. So if I do like 0.6 minus 0.38, that's going to get me 0.22. And we're looking at what is the probability that they will lose when they score 5 or more runs. So we are assuming that they score 5 or more runs. So all this bottom stuff, we could kind of like cancel out and just kind of focus on the top part. So I'm just going to kind of circle that in like orange. And if I do 0.6, so if I look at lose over total, I'll have 0.06 over 0.44. And then I'm just going to divide that, and it says to the nearest thousandth, so that's 3 decimal places. That's going to be about 0.136. So we have about 13.6% chance of losing in that situation. Let's look at a more difficult two-way table. It's actually not difficult in terms of math. It's just more in the table. So this is the highest educational attainment of all adult residents in a certain town. If a resident who has a master's degree is chosen at random, what is the probability that they are all aged 30 to 39? So I'm going to just focus on the 30 to 39 section of the table. And it says, if a resident who has a master's degree is chosen at random, what is the probability that they are aged 30 to 39? So we are going to be focusing on the master's degree row. So we only care about people with master's degrees. And within that world, we want to know the number 30 to 39, given, and this symbol here means given that they have a master's degree, over number of masters. So I'm going to do 688 over 2797. And that's going to be 0.246. So about a quarter of the people with master's degrees in this survey are in that age 30 to 39 range. So that is it for conditional probabilities. We will be having our mastery over probabilities at the beginning of next class. So we'll have a little bit of time for review on that.